Hello, my name is Professor Adjovan, and this is episode 16 in the Quadratic series. And in this video, we're going to look at how to graph a quadratic that is in standard form. We're going to look at three examples in this video. The examples are on your screen now, so if your homework problems look like these examples, then this is the correct video for you. If you're looking at these and you're confident that you can graph these already, then I would recommend going to the next episode in the quadratic series. For everyone else, we're going to go ahead and jump into it. So a standard form quadratic is in the form of ax squared plus bx plus c. And I'm using this functional notation f of x. If you're confused with what this means, it's basically like saying y equals, but a little more formally defined. Basically, I can replace this x with, let's say, 1, a number. That means that I also replace the x everywhere we see it in the problem. So it lets us better define and keep track of inputs if we're going to let x be equal to something than we would get if we were to say y equals. Alright, now in order to graph a quadratic, specifically in standard form, we're going to need to come up with a few different things. The first thing we're going to have to come up with is a vertex. We're also going to need a y-intercept and some x-intercepts. These three things will help us, for the most part, graph whatever quadratic we have. And then after we graph it, we're also going to want to come up with the domain, the range, and the axis of symmetry. So the vertex of a standard form quadratic, there's actually a formula for it. Okay, the vertex is a point, so it's a coordinate point, an x and y coordinate point. The x coordinate point in it is going to be negative b divided by 2a. And that's the b and the a from the ax squared plus bx plus c. The y coordinate is going to be whatever this number is, we're going to plug it in for x, and the output that we get will be our y value. So I'm going to write this as f of negative b over 2a. Meaning we take this x value, whatever it is, and we plug it into the equation, and we get some output y value. A y-intercept is always going to be 0, comma c. Right? A y-intercept is when the function crosses the vertical line, x equals 0. And this is always going to happen at c. X-intercepts, we can solve for this a number of ways. The way that I would recommend that you solve for this, because this is in standard form, is to use the quadratic formula. And that'll tell you where your x-intercepts are. You could complete the square, you could try to factor and solve, but the quadratic formula is really designed for when this is in standard form. Alright, and the x-intercept is when y is 0. So if we get two solutions, we're going to have our first x value and our second x value, x1 and x2, and then y's are going to be 0. We know that domain is always from negative infinity to infinity because these are parabolas. The range is going to be negative infinity to some y value, or some y value to positive infinity. And the axis of symmetry is always going to be x equals negative b over 2a. If you're confused about this domain and range, it's something we talked about in the last episode of this quadratic series, so go ahead and watch that if this is confusing, because we really dove into it and looked at how to come up with domain and range and where these come from. All right, so now that we have all this kind of defined in a general sense, let's try to do it and put it all together with a few concrete examples. Starting with f of x equals x squared plus 4. So let me first make this a graph. And we'll put some axes in here. There we go. So the vertex is going to be at negative b over 2a. That's going to be the x value of my vertex. Well, I don't have a b value. I don't have an x in here. So negative 0 over 2 times 1 is just 0. So the x value of my vertex is 0. And f of 0, if I plug it in here to get the y value of the vertex, 0 squared plus 4 is not 0. 0 plus 4 is 4. So my vertex is at the point 0, comma 4. We can put that 0, 4. The y-intercept is at the c value. Well, this is convenient. The y-intercept and the vertex are the same point. So in order to find the x-intercepts, we need to solve this. Now, like I said, we can use the quadratic formula, we can factor, or because this is missing a b term, we can just set this equal to 0 and solve for x by isolating it and then taking the square root. And when we get to this point, we take the square root of a negative. And when we did this a few episodes ago, we would say no real solutions. What this means is that this parabola, this quadratic, is not passing the x-axis. It is never going to intersect it. So if this is my vertex, and it's the y-intercept, and my parabola is never going to intersect this x-axis, that makes sense because a parabola could be facing up, it could be opening up, or it could be opening down. So because there is no real solutions, it must be opening up. And we can give it a quick sketch. If we did get a solution, whatever those points were, would be our x-intercept, and that would make our parabola. But that did not happen in this example. Alright, so we found x-intercepts, there weren't any. We found the y-intercepts in the vertex. Now we need to define the domain, which we know is all real numbers, negative infinity to infinity. The range, because this parabola is opening up, it's going to be the y value of the vertex to infinity, 4 to infinity. The axis of symmetry is x equals the x value of the vertex. So axis of symmetry, x equals 0. So with all of that, we've graphed with a sketch, really. It's not exact, but we've graphed the parabola, and we've labeled all of the necessary information. Everything that's important, all of the characteristics about this parabola are labeled here. Okay, so it's not just enough to graph it, we want to make sure that we have everything labeled as well. Let's go to another example. Again, we'll add a graph to this. Okay, and it's really up to us where we want to start with solving for all the different pieces. You don't have to do vertex first. You can do x-intercepts first. You can do y-intercept, whatever you like. To keep it consistent, we're going to do vertex first again. So we're going to take our negative b, there we go, negative b over 2a. So that's negative 8 over 2 times 2, which is negative 8 over 4, which is negative 2. So the x value of our vertex is negative 2. If we plug this into the equation, taking f of negative 2, we can plug it in for all of the x values. Negative 2 squared is 4, times 2 is positive 8. 8 times negative 2 is negative 16, and minus 3. So 8 minus 16 is negative 8, and minus 3 is negative 11. So our vertex is at negative 2, negative 11. So negative 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way down here. Our y-intercept is probably the easiest thing to find when graphing in standard form because it's just a c term. So our y-intercept is 0, negative 3, 0, negative 3. And now we need to find the x-intercepts, and we can do this by solving. We could try to factor this, but we're going to quickly see that it's not factorable. We can complete the square, or we can just jump straight into using the quadratic formula, which is what I'm going to do. So x is equal to negative b, so negative 8, plus or minus the square root of b squared, so 8 squared, minus 4ac, so minus 4 times 2 times negative 3, all over 2a, or 2 times 2. So we get negative 8 plus or minus the square root of 64. Negative 4 times positive 2 is negative 8, and negative 8 times negative 3 gives me positive 24. This is over 4. So we have negative 8 plus or minus the square root of 88 over 4. And then let's simplify this by doing a little bit of side work over here so that we can simplify the root 88. I can rewrite the square root of 88 as the square root of 4 times the square root of 22. And the square root of 4 can simplify into 2 times the square root of 22. And if I have a negative 8 plus or minus this, all divided by 4, we can simplify this 2, this 4, and this 8 because they are all divisible by 2, and end up with x is equal to negative 4 plus or minus the square root of 22 all over 2. So this, as ugly as it is our x-intercepts. We need to take negative 4 and add the square root of 22, and then divide it by 2, and then negative 4 and subtract the square root of 22 and divide it by 2. Now I'm assuming you don't get to use a calculator when you're doing this in class, because if you could, you would just graph it on your calculator and you wouldn't be doing all this work. So how can we approximate where this should be on our x-axis? Well, we can think about it. We can think about the square root of 22. The square root of 22, where does that lie? Well, 4 squared is 16. 5 squared is 25. 22 is between 16 and 25. So the square root of 22 must be between 4 and 5. Okay, that kind of number sense will be very beneficial in algebra and as you get higher in math. So we know the square root of 22 is somewhere between 4 and 5, and we're just going to kind of approximate. If I take negative 4 and I add something that's between 4 and 5, I have something a little bit bigger than 0. And if I divide by 2, I have something just a tiny bit bigger than 0. So we're gonna approximate and say right about there. If I take negative 4 and I subtract something a little bit bigger than 4, I'm at negative 8 point something, and if I divide by 2, I'm at negative 4 point something. So 1, 2, 3, 4, and a little bit. Okay, so how are we going to write these? X-intercept is going to be negative 4 plus square root of 22 over 2, 0, and negative 4 minus the square root of 22 over 2, 0. So now we just need to graph this. We need to connect all the dots. So I'm going to do my best. Ooh. Yeah, that's good enough for me. I would like this to be a little more curved, but good enough. So we have just a few more things that we need to identify. We have our axis of symmetry, being x equals the x value of the vertex, negative 2. The domain is always negative infinity to infinity. And the range, because this is opening up, is going to be the y value of the vertex all the way to positive infinity. So negative 11 to infinity. We have our parabola graphed, and we have all of the important information labeled and all of the supporting work shown. All right, we have one more example to look at. We have f of x is equal to a negative 1/2 x squared minus 5x plus 2. How is that negative 1/2 going to affect things? Well, let's see. The first thing I'm going to do is find the vertex, negative b over 2a. So that's negative negative 5 over 2 times negative 1/2. So negative negative 5 becomes positive 5, and 2 times negative 1/2 becomes negative 1. So we get negative 5. If I plug this in for x, we have negative 1/2 times negative 5 squared minus 5 times negative 5 plus 2. Negative 5 squared is 25 times negative 1/2 will give us negative 25 over 2 minus negative 5 times negative 5 becomes plus 25 plus 2. So I have negative 25 over 2 plus 27. And you can either think of this as a fraction, as negative 12.5 plus 27.5 gives us 24.5, or sorry, 14.5, or we can simplify this to all be a fraction and say that this is negative 25 over 2 plus multiplying this by 2 over 2, 54 over 2, which will give us 19 over 2. Because they have the same denominator, we can add the numerators. Negative 25 plus 54 is positive 19. So our vertex is at negative 5, 19 halves. So negative 5, 1, 2, 3, 4, 5, and 19 halves, which we know is 14.5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way up here. That's our vertex. Our y-intercept, thankfully, is very easy. it's just going to be the positive 2. So y-intercept is at 0, 2 over here. And now I need to solve this. We can solve this using the quadratic formula. I'm going to do it down here. Hopefully we have enough room. X is equal to negative 5 plus or minus the square root of negative 5 squared minus 4 times a, negative 1/2, times c, positive 2, all over 2a. Alright, negative 5, that's a positive 5, plus or minus the square root of negative 5 squared, well that's 25. Negative 4 times negative 1/2 is positive 2, and 2 times 2 is 4. All over 2 times negative 1/2 is just negative 1. So this negative 1 is just going to change the sign of both of these terms. We have negative 5, and because we're going to end up adding and subtracting this, whatever this number is, we can just keep it as adding, subtracting. That's fine. And this is the square root of 29. Alright, so this is our final answer. Now where am I going to put this on the x-axis? Let's think about this, use some number sense like we did in the last problem. Where is the square root of 29? Well, 5 squared is 25, and 6 squared is 36. So it's somewhere between 5 and 6. If I take negative 5 and I add something a little bit bigger than 5, I'm going to end up with something a little bit bigger than 0. And if I take negative 5 and I subtract something a little bit bigger than 5, I'm going to end up with something a little bit smaller than negative 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll say right there. And now we just need to connect all of our dots. Good enough for me. I would accept that from my students. So let's finish this up by just labeling what we have. We have our x-intercepts are at negative 5 plus root 29, 0, and negative 5 minus root 29, 0. We know our domain is always negative infinity to infinity, and the range this time is negative infinity all the way up to the y value of our vertex, 19/2. And our axis of symmetry, AOS, is x equals the x value of our vertex, negative 5. Alright, so we have our graph, and we have all of the information that we need. I've tried to pick some problems that got difficult and very involved because there's a lot of different ways that you can see these types of problems. So hopefully one of the 3 problems was about the difficulty level that you need. I know this video was quite a bit longer, but graphing quadratics is one of the most involved parts of doing quadratics. If you found this video helpful, please consider giving it a like. If you have any questions, comment them down below and I'll do my best to answer. If you have a suggestion for something that you want me to cover, you can comment that as well. And consider subscribing for more math lessons. Thanks, and we'll see you in the next one.